Hello everyone. Today we will discuss about a very simple problem, that is to reverse a linked list. So to begin with, let's take a look at what exactly is a linked list and the variants that it supports. Okay, so a linked list has two components. One of the component is a node and the other component is a connector. So this is basically a node which hosts certain value, and this is a connector that connects both these nodes together. So in theory, a linked list is basically a collection of nodes that are interconnected to each other in a sequential order. There are two variants of a linked list. The one that is on the screen right now is basically a single pointer linked list because it connects two nodes together using a single connector. The another variant is called a double pointer linked list because it has another pointer that basically points back or points from the next node to the previous node. So what we will be discussing today is to reverse a linked list, a single pointer linked list, because there is actually no need to reverse a double pointer linked list because it already has a pointer in place that allows you to traverse from the left end or from the right end. Okay, so let's begin with the algorithm for reversing our linked list. Okay, so let us assume that there is this linked list that we have and it has a few nodes in it. So okay, so we have a linked list now. So how it works is, so assume that it also contains some values. So once this linked list is reversed, right, so the order of traversal should change, or more like, if we traverse this linked list and let's say just print the elements, then after the reversal it should basically print these numbers in the reverse order. The working of this linked list is pretty simple. What it does is to split the linked list into two parts during the traversal and keep on adding nodes from the original list to the new list, which eventually will become the reversed form of the original linked list. So now let us take a look at the code of how we can achieve this uh, reversal, right? So what we will be needing is a few additional pointers, right? The first one would be a previous, right? And then there will be another pointer which we will call current, and then a third pointer which we can maybe call a temp pointer, right? So initially these pointers will basically be pointing to some specific nodes, right? So let's say that the current pointer is pointing to the head. This is the head. Then the previous is initially pointing to nothing. It is just pointing to null, right? And then there is a next node, which you may just point it to the head for now. Okay. So the algorithm looks something like this. While current is not null, what we are supposed to do is, the first thing that we'll do is to basically point next to the next of the current node. Then we will do current dot next equals to previous, and at the end we'll do previous is equal to current and current is equal to next. So let us now trace this algorithm and see how it works. So in the very beginning, what we do is we basically check if the current node is not null, which in our case is not null as of now. So what we'll be doing is we'll basically start pointing the next pointer to the next of the current, right? And then we'll basically sever this link here, right? And the next of current will now point to the previous node. So at this point of time, if you see, there are basically two distinct linked lists, right? One which is a sublist of the original one and the other one which we have just created. Then the next step is to kind of move forward the two pointers that we have. The first one is the previous. So previous will then basically start pointing to null and pointing to current, sorry, and the current will basically start pointing to next. So at this point of time, this is now current, right? And this is previous. Again, we'll basically traverse the linked list, right? And see that, okay, the current is again not null. The next is step again is to basically move forward the next node or the next pointer. And then we'll basically sever this link again. Now this is the linked list and this is another linked list, right? So at this point of time, there are two linked lists and the next step is again to basically move forward the previous and the next, the previous and the current nodes, right? So this becomes previous and this becomes current again. So this eventually will basically come to a stage where the current value will basically become null. So at this, so there will be a point when the current, this will basically become current, right? And at this point of time, what we need to do is we basically need to return the previous node. So this will be the previous node. And this is how this algorithm works, right? It's pretty much straightforward. What we need to just understand is that with each iteration, the linked list is going to be kind of split into two, right? And eventually what will happen is the original linked list will basically shrink to a point that it holds no more nodes, and the new linked list will basically start to kind of increase in size by taking up one node at a time from the original linked list. So this is all. Yeah, thank you.